participants are now in listen-only mode.
A warm welcome to all of you to this IBM Big Data Virtual Event 2013. This is the second in the series of the event, the first one that we conducted last year. So this is Bharat here, and I'm a Big Data Manager in IBM ISL. And I'll be walking you through the keynote highlights for this particular event. The keynote itself, the full version of the keynote will be posted on the community site as well as on the YouTube channel, and we will be sharing the links with you. To start off with the normal disclosure, so all roadmap-related information is only for guidance purposes and are not binding at this time. So let me start with IBM's overall vision for big data. So the way IBM basically looks at the entire big data platform that we support is really to provide SOA services across the breadth of data in organizations today. So we have data coming in from different sources. We have streaming information, we have structured, unstructured textual information, we have time series information, we have image and video information, and not to say Facebook and Twitter, all the social media likes of information that's flowing into organizations, into corporates. And the way IBM is positioning its stack is basically to have an ingestion mechanism to these various types of information that's flowing in. Let it be real-time analytics, or let it move into BigInsights Hadoop. So that's where you see either you get into a real-time zone or you get into a landing zone of BigInsights Hadoop. And definitely you will yet continue to have your master data management and your warehouse zone, which you see sort of now moving to the right-hand side, the enterprise warehouse zone. And in addition to this basic platform, what we are proposing is to provide you capabilities around advanced analytics so that your applications, either your existing applications or new applications, can harness the power of big data to provide these advanced analytics. It's just not predictive analytics per se, but we are moving on to the paradigm of prescriptive analytics, where you also understand what should be done with outcomes that are being predicted. And that's really the whole phase of exploration and discovery that's possible in the big data world. And to talk about applications per se, IBM definitely has the Watson application, which basically is sort of bringing intelligence to the machines, and you end up having analytic applications, the IBM SPSS or Cognos, or even cloud-enabled applications or ISV custom applications that IBM Big Data Platform is really geared to support by this SOA model. Now, on this particular slide, I'm giving an overview of how really this architecture spans out. If you look at IBM architecture, it's no way a closed architecture. In fact, we are strong believers in having an open ecosystem where our partners can basically plug in their custom applications to basically leverage the platform. So it's really a hybrid architecture that is being positioned. And to the left-hand side that you see on this schematic is the acquisition fabric. So like I mentioned, you have data from all these sources that are coming in, structured, unstructured, or even relational sort of schematic data. And now to gear to this acquisition fabric, we have these ingestion mechanisms that we are placing, whether streaming or it could just land up on BigInsights Hadoop. And once your ETL processes, basically your cleansing and moving data to say a columnar store, all that is done, that's where we sort of evangelize moving this data to the exploratory zone or the warehouse zone on the right-hand side that will support your whole fabric of your analytic applications. And then that's where it's the access fabric, where your BI applications, your analytic applications can hook on to your existing warehouses. It could be pure data for analytics, which is really our extended version of the warehouse to deal with the science of the truth per se. So in this particular slide, I give you a more granular picture about how IBM's big data platform, from a portfolio standpoint, basically plays out. So you see, we have a whole plateau of portfolio across InfoSphere. So we have InfoSphere Streams, which is one of the best in breed, products to deal with the real-time event analysis, real-time streaming information. And similarly, you have the InfoSphere BigInsights, that your extended warehouse can basically store your raw and unstructured information. So all this data that's flowing in now can basically be consolidated in these systems, which in turn will move to your operational data store, And that's where the information server paradigm comes into picture. And now with my information server, I bring in all the capabilities of my traditional data warehouses, my information governance, data quality, my ETL tools come into picture, which finally now are being consumed. The data that moves into the warehouse will now be consumed by the end applications, which are SOA enabled or your supply chain applications. So from a portfolio standpoint, if you look at it, we have the entire range of portfolio from streams to BigInsights to information server to basically cater to this entire ecosystem. So in consolidation, really the rule is that the whole is greater than the sum of its parts. So if you look at the entire portfolio that IBM basically positions, we have streams, we have data warehousing, pure data for analytics, and underlying it is your information governance portfolio. And we do have a packaged layer called the accelerators, which basically provide custom industry solutions to different verticals like the telco or finance vertical. And basically on top of that, like you see, we have this entire systems management or the entire development ecosystem that we support, in addition to visualization and discovery. Because visualization is one of the key aspects of big data. Because unless you're able to visualize information, you'll really never be able to come to concrete analysis. And that's one of our key points, that we definitely cater to that aspect also. And with this platform, definitely you can build your analytic applications like the red box on top. So it's really a comprehensive stack from an overview standpoint. In this slide, I'll touch upon what are the prime business use cases that IBM is positioning for big data. So nevertheless, in the whole plateau of requirements around big data that are emerging, the 5 concrete use cases that we essentially nailed down to start with is primarily big data exploration. Because now what's happening is the major telcos or the major corporates, the Fortune 500 companies, as and when they're getting into the big data realm, they have all this data coming into their systems. And now I think the starting point is really exploring this information. Because big data is all about a what analysis. You basically try to do a correlation analysis. You try to correlate events. You try to say, what can I make out of this data? And that's where your exploration phase starts. Because big data is never a paradigm around why. Why things happen is not what big data is concerned about. It's rather the correlations that are important, so that I can sort of come up saying that these are the correlations that exist, and this is the best use how I can use these correlations. Let it be improvement in your operational processes or understanding the customer behavior. I mean, that's what you're really doing when you explore this information. The second use case is around 360 view of a customer. Now, this is sort of an interesting use case, because what really we are talking about is, so we sort of now envision a customer just not an isolated entity. So the way telcos today or corporates today are looking at customers are getting a complete 360 view of their network. Who are the people that they regularly talk to? What are the chains that they regularly go to? What is their shopping experience like? And probably what are their feed info on Twitter channels, on Facebook channels, and what is their influence circle like? So in reality, in today's world, you walk into a shopper's shop and more or less they will likely know what potentially you're looking to purchase. And then all that information, all that intelligence is gathered by the big data analysis at the back end. The third use case I talk about is definitely around security and intelligence, where it's all about risk detection, fraud detection, cybersecurity in real time. So basically anything to do with the real-time information that's flowing that can basically be harnessed to understand the threats involved is around the security domain. The next use case I talk about is around operational analysis. Now this is something that's important, because you look at it today in this instrumented world, most of the operations we do, most of the transactions we do are really with machines. You withdraw money, there's an ATM involved. Now, if you look at ATM as an example, you have these ATMs across the country, and all of them generate machine data. Now, understanding basically what is the possibility of these machines coming down could be an example of log analysis, of basically understanding how you can basically have an uptime for these machines in an optimal way. And believe me, in today's instrumented world, it's all about understanding these instrumentation devices. What is the best way to capitalize on them? And definitely that's like a hot spot for the corporates. And that's where operational analysis and improving your productivity and improving the way systems function is a prime business use case. And it could really involve just analyzing these unstructured log information being emitted by devices. The last use case I talk about is around data warehouse augmentation. So think about it. The way a couple of years back, data warehouses was basically where corporates migrated, where IT divisions migrated all the information as a storage repository. But now what's happening is that these warehouses are sort of being overwhelmed. Basically, they may actually run out of capacity, and it's not even optimal that I bring in all the information that I may not end up using just for exploratory reasons on the warehouse. It may actually bring a downtime to your 24/7 operational productivity on the warehouse. And that's where what corporates are doing is sort of offloading this information from warehouses to a cheaper platform per se, like BigInsights Hadoop. And that's where you no longer make your warehouse the bottleneck, but rather move all the data onto BigInsights Hadoop, do all your exploratory analysis, and once you're done with the analysis, you get your results. All the data that you think is relevant, you sort of bring it to your warehouses so that your existing analytic applications, existing BI reporting can leverage that information. So that's another use case on how basically the whole realm of warehousing and big data is sort of playing hand in hand. On this particular slide, I talk about the accelerator solution that we basically package with our stack. Basically, it provides deep packaged value around specific sectors, let it be the telco sector, let it be the real-time retail customer intelligence sector, the finance sector, the social media sector. So around these, we have specific solutions, frameworks that we provide, which basically are based on the immense knowledge that we have on the domain, and we provide as packaged accelerators per se. We do also cover a lot of standard toolkits that are being shipped with InfoSphere streams and the user-defined toolkits, and not to say the hundreds of sample applications that are provided. So if you think about it, the way IBM is positioning the ecosystem is all around being a partner-friendly model, being an open model, being an extensible model. Because you look at BI reporting. Now, we definitely support IBM Cognos, but nevertheless, you do have support to, say, the external tool like MicroStrategy, which is sort of one of the market leaders in BI reporting. And MicroStrategy today supports IBM InfoSphere BigInsights. And similarly, on the analytics side, we do support SPSS, we do support SAS. And when you talk about it, any of the functional applications, the industrial applications, you can build connectors onto our big data platform to leverage and harness the information. And that's really what we want our partners, we want our integrators to sort of leverage the platform, underlying platform, and sort of enable their applications for the big data world. Now, I briefly touch upon the roadmap of IBM Big Data. Again, these are more of guidance principles, the architectural principles that basically govern our roadmap decisions. We are definitely looking at, or rather, we are a cloud-first design platform. We definitely want all the SOA services that we talk about to be cloud-enabled, to be a part of the cloud ecosystem. And when I talk about intelligent data provisioning, probably an example could be the pure data for Hadoop, where now within appliances you have access to BigInsights Hadoop. And when I talk about application portability or analytic model execution portability, what I really mean is that if you have applications that are basically built on MapReduce, we provide a seamless migration. Because you look at pure data for analytics, that supports MapReduce. BigInsights Hadoop supports MapReduce. So you definitely have that level of portability to seamlessly migrate your applications onto these platforms. And when I say seamless access, definitely all our warehouses, pure data for analytics, our BigInsights Hadoop are today SQL enabled. They understand the common language of SQL, and it's basically all standards compliant. So it's definitely a seamless access again. And having said all this, we definitely are looking for the basic underlying governance, the security model, the access controls that you can define on the platform. And it's definitely a hybrid capability around both structured, semi-structured, and unstructured information that the platform is geared to. And lastly, on in-memory and solid state, yeah, definitely I think that's been a major focus with DB2 10.5 supporting Blue acceleration. I think we are geared towards going that route for our portfolio. So really, in all these paradigms, IBM Big Data is very centrally positioned across mobile, across cloud, across your social teams, and like to say, the Internet of Things, because it's really an instrumented and interconnected world today, and big data is very rightly positioned. Our stack is very rightly positioned in the center in the schematic over here. So those were the key highlights, and again, we do have the link to the keynote, a complete version of this keynote by James, who's our key IBM Big Data evangelist. It's available on the DeveloperWorks community, and the link is also shared on the chat forum. So let me move to the topic of today's session around BigInsights, the Big SQL technology. So really, this Big SQL is something that we actually supported with BigInsights 2.1 release sometime in June timeframe, 2013. So really, what is Big SQL to start with? So Big SQL fundamentally is an industry standard SQL that we support for BigInsights Hadoop data. So what that means is all the data that's on your Hadoop file system today is no longer isolated just to your custom applications, the way you basically read it using the native interfaces. We rather are now providing a SQL interface to all this information. And why? What really is the driving factor? Because really, you look at it today, SQL has become a de facto standard. Most of the corporates, most of your IT divisions have applications that are SQL enabled, and really asking them to understand something new is not a possibility. We'll rather hook on to existing technologies that these applications can leverage, and that's where using the JDBC or your native ODBC drivers, all your applications can now seamlessly talk to a BigInsights Hadoop. And just purely from a SQL standpoint, what are the operations that we support? We definitely all the DDL around create table, around loading the data, around querying the data. So all the basic DDL is supported, all the DML is supported, and strictly speaking, we are SQL 92 and SQL 2010 compliant. And what are the storage mechanisms? Now, natively, BigInsights HDFS platform supports Hive and HBase, and we do support Hive and HBase, and the regular storage of sequence files, or text files on the distributed file system. Okay, so let me move to the next topic on why exactly are we getting into the SQL access for Hadoop? So, like I mentioned in the previous keynote highlight, a data warehouse augmentation is a leading use case. Now, the way really we see data warehouse augmentation in corporates today is they may have a paradigm where they move data onto the warehouse, and then they sort of offload the unrequired, basically the data that's purely required for exploratory analysis onto BigInsights Hadoop. So that's one paradigm we've seen. Or in the reality today also is that corporates are not shying away from moving their data directly onto a Hadoop platform like BigInsights Hadoop. What that means is the data is directly flowing into BigInsights Hadoop, where you basically cleanse the data, you put in your ETL processes, you basically populate the data onto your columnar source as required. And basically for these exploratory analysis that you do, you will yet need support of your analytic applications, of basically having your custom applications that require SQL access. And that's where to basically support the data warehouse augmentation, basically we are providing the SQL interface for Hadoop to enable your exploratory analysis with big data. And also, strictly speaking, if you look at Hadoop as a platform, MapReduce, native MapReduce definitely requires additional skills, and which are not common. And probably you may need to pick up skills on unfamiliar languages like Pig again. And so that's where providing an already known and a familiar syntax of SQL is the motivation factor. So let me talk about the big SQL architecture to some extent over here. Also, I see on the chat forum that people have audio options. So I will say if you cannot dial into the bridge, please go ahead and use audio on your on the computers that you are basically getting into the virtual conference. So on the big SQL architecture, if you look at it, the way the architecture spans is within InfoSphere BigInsights, we have a SQL-enabled server, the big SQL server. And this big SQL server is capable of taking in JDBC and ODBC requests, basically consuming SQL information. And then we have a layer that basically interprets the SQL and basically generates a SQL plan for Hadoop file system. And when I say for Hadoop file system, it could essentially just boil down to a MapReduce plan that can essentially be run on the cluster. So basically, if you have 100 nodes on the cluster, say with 100 petabytes of data, so on the cluster, all these mappers would basically run on the nodes, basically executing the plan that is generated for the SQL. And that's where you see these yellow boxes where it basically showcases how the MapReduce parallelism plays out. And these mappers essentially have the knowledge to talk to the file system, either a Hive storage or a HBase storage, or it could just be sequence files. So coming back to from a standard standpoint, we support joins, we support unions, we definitely support aggregates. From a data type support, I mean, all the basic types are across the varchar, decimal, timestamp are supported in the stack. And our drivers, the client-side connectivity is totally standards compliant, JDBC and ODBC. To talk about some of the key highlights, we do support prepared statements. We do have cancel support. Now, probably you need to appreciate that a cancel support is really something where you have mappers running across, say, across hundreds of nodes, and you're able to cancel the execution of that particular query of those particular mappers across these nodes. So that's the level of support that we provide. And you will have all the metadata information available via APIs for your custom applications if you really need to harness the catalog. And definitely there is support for security for the SSL layer. So from an optimization standpoint, if you really end up running queries which are sort of low latency queries, you really need not run mappers across the cluster. You can define something called the local mode, and in this local mode, basically you can run the query directly on the server to basically get immediate results, basically all the low latency queries. Or if it's really a job that has to run on the cluster, you can, by default, it would run in the MapReduce parallel mode. And when we talk about integration, we really support the entire ecosystem. Let it be Eclipse tools. You have BigInsights plugins onto Eclipse where you can actually go ahead and program for BigSQL. I have a slide later on for that. And you do have connectivity to a DB2 or a Teradata or a Pure Data for analytics using the load commands. And having said that, all the business intelligence support around Cognos, around MicroStrategy, see around the Tableau, where customers are already used to these tools, to these technologies, are seamlessly supported with BigInsights, BigSQL. So to drill down a bit more, to give you a much more better feeler about this entire BigSQL technology, so the invocation options around BigSQL, you have a command line interface, the JSquash shell, and you can basically run all your commands, the SQL commands on JSquash, and actually you can build applications, you can actually do scripting around our command line interface. Probably that's maybe something more favorite for DBAs. And we do have support around the web-based interfaces, the BigInsights web console. You can actually fire queries on the web console, get results. and the likes. And we do support a programming environment around Eclipse. So you can actually basically download the BigInsights plugin and configure it with for your JDBC driver and actually do a big SQL programming. So now I talk about the basic support, the SQL support, just to give you a feeler on the DDL that is being supported. Probably in the future slides, one key thing I'll probably want you to understand and appreciate is that we are a SQL-enabled technology. We basically enable you to talk SQL to Hadoop. But having said that, the intent is definitely not to make Hadoop a relational database. That is not the intent. We do not support transactions. We do not support all the other advancements that RDBMS supports. And because that is not our intent. There is no intent to support transactions per se. So, but nevertheless, we want big data to be consumed by business intelligence applications, by analytic applications from a SQL standpoint, so that the data can be harnessed. And that's really what the intent is. So that's something that you will need to appreciate. So talking about SQL syntax, so you can see we do support the create table syntax, and we also in this create table you can see there is sort of Hadoop extensions, or basically I can specify the row format. I can say how I'm storing these files as a sequence files or a text file. So all these are sort of extensions to a regular DDL that you would probably use with a DB2. And like you mentioned, we do support varchar decimal, and as of Hive 11, versions prior to Hive 11 do not support varchar or a decimal. And on this slide, just to give you a layout, when you actually end up creating a warehouse table, it actually gets stored onto the warehouse directory, to be more precise, under the schema. The schema is just your collection of tables, just like any other regular database concept. And you can actually go ahead and define external tables and map on these external tables to files onto your file system. And we'll talk about the catalog in the further slides. So this is more of a layout on how, when you create a table, the underlying files are created and where data is stored. And this may actually become more interesting when you actually try partitioning your tables and have a partition level directories being underlying created. So we do support other extensions to Big SQL. But before that, the data types around binary, varchar, decimal, like I mentioned, we do have standard support for them. And you can actually at a column level, you can specify the null and the not null indicators. Now again, since we are really not a relational system, we do not enforce a null or a not null. The only reason we support these DDL syntaxes is so that you can, when you migrate from a warehouse onto BigInsights Hadoop, we definitely do not want you to lose any relationship information, any constraint information per se. So and that's one of the reasons. And the other reason is the optimizer within Big SQL can leverage the information if it's a not null column to basically optimize the rewrite of the query. So if as an example, in case you have nested queries and there's really not null columns being used, the optimizer could very well elevate the nested query onto a join operation for better performance, just as an example. And other hints like table size equal to small, that will sort of force the optimizer to look at a plan generation which is sort of local to the node and really need not go the MapReduce route on the cluster. And around HBase, we do have a comprehensive support for the HBase columnar data store. You can define your column families, your column mappings, and other options. So one of the key requirements will definitely be around populating data onto BigInsights Hadoop. So really the data can be loaded in various ways. It could just be a direct file copy onto the local file system, or like I mentioned, you could just map your external tables to existing files. Or we do have connectors to Pure Data for Analytics or DB2, or even Teradata for that purpose to basically pull in data onto BigInsights Hadoop. You have the load Hive command as shown on this slide, which actually you can end up actually copying the data or moving the data. And you also have control over the format of the file that you may be interested in. Like if really your application is geared towards high performance, you may actually end up storing the file in binary format, if that's your requirement. And we do also support a single row insert onto HBase table. So you do have support for the insert statement for HBase columnar database. And the load syntax for HBase, again, automatically basically handles the encoding, the composite keys. And there is support for indexes on the columnar store. So let's talk about querying the data. So to start off with the very basic, we do support the projections. You can define your projection list in your select statements. And from a restriction standpoint, yeah, you can put in your predicates and restrict the amount of data that you may be interested in. There is support for union. There is support for difference and the intersection clauses. And definitely we do support the joins, the subqueries, and the built-in functions. I have more on the coming slides. So as far as join is concerned, we support both the ANSI join syntax and the common join syntax per se. So in the examples that we've shown, you can directly join the tables and put the predicate or where clause, or you can explicitly use the ANSI syntax of specifying the join keyword, opposed to Hive that only supports the ANSI join syntax at this point. Also, another interesting thing probably you have seen in some of these queries is that some of these tables refer to TPC-H. And in fact, the entire TPC-H bucket is sort of certified with BigSQL, just as a note. So when I talk of subqueries, we do have support for subqueries. You can have nested queries within your query. And the optimizer can actually optimize this to be a join based on applicable optimizer policies, and Hive does not support subqueries at this time. So to talk about aggregates, so BigSQL does support the concept of windowed aggregates. You can actually go ahead and use the over clause where over specific partitions or over specific time periods you can extract out information. Like say you're doing a sales forecast, or you're doing a sales forecast, say for the fall season. You can actually go ahead and limit the information to do the forecast around that particular period and basically use the over clause around it. And like this example, across different years, you can see that your sales calculations are being done. So yeah, so in totality, the way we are sort of bringing out BigSQL is that it definitely caters to all your advanced analytic requirements, which probably the open source stack will not be able to satisfy. So on this slide, we do have a whole plateau of functions that we support around numeric or trigonometric, the string functions, textual functions, the date functions, and aggregates. So we do support all this. I have a standard support around all of these. And coming to catalog, so basically we have the capability for the end application to harness our catalog to figure out basically what are the tables involved, the schema involved, the column types involved. So we do support the syscat tables and syscat columns, basically it's a way of getting information. And this could actually be a big help if you actually end up developing applications that are heavily based on metadata. So basically, if you need to fetch metadata and store your own custom metadata, I think this level of support is very much required. Since really we're looking for an open platform where you can have end applications seamlessly dumping their own metadata onto BigInsights Hadoop. And like I previously mentioned, we do have support for standard SQL with the Eclipse. In Eclipse tooling, you can get the plugin and actually end up writing SQL queries which are more user-friendly from a syntactic standpoint, where the plugin gives you the capabilities of a good UI interface itself per se. We do support the other open source tools around building standard SQL capabilities, Squirrel SQL, for an example. You can configure the JDBC driver and use the plugin. So in the next couple of slides, let me brief about our support for business intelligence applications. So like you see in the schematic, we are supporting Cognos BI server with InfoSphere BigInsights. So what essentially happens is that Cognos will basically ship customizations. It'll have a custom configuration for InfoSphere BigInsights. And this configuration basically determines to what extent is SQL pushed onto BigInsights, what are the predicate, what are the functions that BigInsights supports that really they want those functions to be basically executed within the BigInsights platform. So all those customizations will be defined on Cognos BI, and using the native JDBC interface, it talks to the BigInsights platform for exploratory analysis, for reporting. That Cognos is pretty standardly known for. So just like any other data server, BigInsights actually ends up to be one more data repository that Cognos is supporting as of today. So from Cognos, I move to the MicroStrategy platform. So if you look at the MicroStrategy platform, basically which spans across web, mobile, portals, and your office applications. Now this particular platform is very well capable today of talking to InfoSphere BigInsights. Like you see, you have data across the enterprise at the bottom of the screen, which could very well end up in relational databases, in data marts, and in your different data sources. Now, and BigInsights is now a new addition where MicroStrategy is capable of communicating with BigInsights and pull out the data. So to get a more deep dive into this, so like you see, all your comprehensive analytic capability around benchmarking, your relationship analysis, your projections are now actually sort of being fed back onto BigInsights Hadoop. The actual models are being executed on BigInsights Hadoop to basically get results, and now which are being published on the intuitive MicroStrategy front end. So from an end user experience, the front end would yet be the same, but all the processing of data would now happen on BigInsights Hadoop. But having said that, you'll also end up processing semi-structured, unstructured log information on BigInsights Hadoop, which was previously not possible. And so really the time to value as far as business is concerned is really the prime driver around this integration. To give a more deep dive, so what really happens under the covers is that so MicroStrategy, the way it does OLAP processing, it actually starts building this business intelligence cubes. It fetches information out of BigInsights, BigSQL, builds these business intelligence cubes for BigInsights, and then based on the query, it dynamically basically gets the operation done on these OLAP cubes that are being built. And these cubes actually could be built across varied data sources, and they have this nice capability of basically joining the cubes and basically forming a union when required. So all that capability, which is standard MicroStrategy, is onto the play with BigInsights integration. So it also sort of, looking at it from another angle, gives you the capability to federate, because you can define BigInsights as an additional repository, continue to use your RDBMS, and then the entire cubing technology, where the OLAP cubes are built across BigInsights and RDBMS, are being used to service the results. So in a sense, you also sort of get into federation with this integration. And not to say all the other standard integrations like the MicroStrategy Office with MicroStrategy Excel, you can go ahead and connect to BigInsights Hadoop. You can basically define your native ODBC driver, your DSNs. You can configure Excel and basically pull out information from Hadoop, from BigInsights Hadoop. And once you have the information, you can definitely get into reporting and other calculations on your Excel. So now I talk about SERDES. So what really are SERDs? Now, what's happening in the big data world is we really are heavily geared towards, say, the social media channel, to social media data, unstructured data, log data. Now, all this information is really, it's no longer the traditional relational sort of a format. It is no longer a simple ASCII format, but it's rather a nested layout. It could be a JSON layout. Look at Twitter feeds. Look at Facebook feeds. They really follow a complex nested pattern similar to a JSON layout. And that's where when you actually load data onto BigInsights, you can actually go ahead and say in what format do I want to load the data? What is the encoding that is applicable? And we basically define that by an abstraction called as a SERD to basically read or write complex data formats. And you have a standard procedure. You can use an open source SERD, or you can define your own SERD for the data in question. And then when you can define your table with that SERD and load data using that particular metadata definition of the SERD. So to give you an example, so I have feed information in this particular slide. So in this feed information is coming from the social media channel. And now if you look at it, it's all unstructured content. And now using my SERD, I try to define, basically give a layout to this information. And when I load it onto BigInsights Hadoop, you can see a format that's coming out. I have my author information, I have my feed information, I have the time at which it was inserted, so that now actually I'm more geared to do a concrete analytic operation on this information. So and that's really what the paradigm is, because whatever unstructured content you have, at the end of it, to perform analytics, you need to basically migrate that unstructured content to some structured content. You need some metadata around the content to carry out analytic operations. So quickly on the performance front, we definitely are geared towards, from a performance standpoint, we are geared towards high performance. Like I told you, we do support the TPC hedge bucket. And from a tuning option standpoint, you can actually define the storage formats. You can define your column families for the columnar store. You can actually put in hints in your table definition in the DDL, or you can even put in hints to your queries. And you can actually go further down and put in go and actually code for your MapReduce job properties. So to give an example over here, if you look at the query hint that is supported, we are providing the access mode as local, which essentially means that all the query execution happens on the local mode, happens on the single node of the big SQL server. You can also actually go ahead and define hedge-based secondary indexes for faster execution. So you have this whole plateau of options that are available to you in terms of hints. And the hint syntax is really a standard comment sort of a syntax for SQL that we support. And the example that I've provided is really in the DML, but on table definitions, you can go ahead and provide these hints for the table itself. And lastly, I'll consolidate over here in the next couple of slides. So what really you need to know from Big SQL and sort of draw a parallel to RDBR, to the relational system. Like I mentioned, so what we are providing is a SQL Access industry standard query support. And with the SQL Access, we are putting in Hadoop-specific extensions. We are introducing Hadoop-specific concepts like the SERDs and other unconventional data structures that we end up supporting. And it's really, the theme is not to build a relational database system out of Hadoop, because I don't think that is possible. We do not support transactions. We probably do not have the rich catalog statistics that exist on databases, because that is never the intent. And I've given other examples like a 3GL support or a COBOL support is really unlike what a traditional data warehouse would support. So lastly, I'll leave you with this slide. Now, probably this is some food for thought. So think about the way the slide is architected, the block diagrams on this slide. So if you see, this is an emerging pattern based on all my discussions over here on the previous slide. This is really what is emerging in corporates today. You have information that's flowing in from different channels, from the instrumented world, from the interconnected world, from your social media channels. all that information flowing into your real-time analytics zone on the top left box, which is basically your InfoSphere streams, the best in breed products for dealing with real-time event processing. And then once it moves on through InfoSphere streams, it can actually go through the ETL process. The data could get transformed. You can have your analytic results, which finally may end up moving to your warehouse zone. So the key is that your warehouse zone is moving more towards the right. And on the other side, of the bottom left-hand side, you see your analytic zone. Your landing zone is again BigInsights Hadoop, which is basically where the information is not being streamed in, and you rather have ingestion mechanisms. And you would end up moving the data onto BigInsights Hadoop, carry out your MapReduce programming, carry out your analytic operations. You may actually end up filtering the data and then moving it to your columnar stores. And underlying all this is really your metadata and governance of the InfoSphere portfolio that comes into play. And from an architectural standpoint, from a hardware standpoint, like I mentioned, we definitely want this entire ecosystem to be cloud-enabled for high availability, for security, per se. And to the rightmost side, you see all your reporting zone, your current applications that would exist, your new applications that can be built to support this big data platform. And the warehouse zone would actually continue to be around the pure data for analytics and the InfoSphere warehouse. So, and you look at the bottom, we will support all these integrations around R, around SAS, around SPSS, around Java MapReduce. So all those integrations would continue to be supported. So as a holistic standpoint, holistic viewpoint, this is where the IBM Big Data platform is headed to. And this is really the architecture that probably you can keep in mind when you actually work on your projects around big data. And this architecture, the other nice thing is that it's really common across industry verticals. We've seen it in the automobile sector, the insurance sector, the telco sector, the financial sector. So around all these sectors, this is the common emerging pattern. So lastly, I'll leave you with basically more from a learning standpoint. We have BigInsights, Big SQL tutorials available on IBM Product Information Center. We do have a technical enablement wiki. It's a public wiki that's available. And definitely all the BigInsights tutorials that get bundled with the install. And the Big Data University, which is again hosts a plateau of information around the IBM Big Data stack. Also, we sort of announced the launch of this IBM Big Data India community. So it's a developer works community where we've essentially hosted this program, this virtual event. And I would strongly recommend all developers to actively participate in this big data community. Get yourselves registered and actively participate. We can use this as a channel to sort of share information, because really I think the way the technology sector is moving, it's all about collaborative sharing. It's all about collaborative learning. And this is just the initial step to achieve that. So I conclude my talk, and I will open the lines for Q&A. And also, while we are in the Q&A, there will also be a poll conducted, an online poll that Apra will be helping me with. So do participate in the online poll, share your feedback. That's going to help us basically better serve these virtual conferences going ahead. So I'm opening the line for Q&A.
All participants are now in interactive talk mode.
So I will request any Q&A, the user can basically give his name and the company he belongs to, and go ahead with his question. I will also be looking for questions on the chat channel, on the chats that are coming up, and I will try to address either on the or the yeah.
Hey Bharat, this is Kumar from Infosys. Thanks, it's a wonderful session. I have one query. Can I call whether BigInsights can be in one of the Hadoop distributions?
See, the way we have basically positioned the BigInsights IBM Big Data Stack is that Hadoop is an underlying offering. So we build on top of the Hadoop ecosystem. We support Hadoop ecosystem. We are strong supporters to the Hadoop ecosystem, and we bring in value-added services. We essentially take Hadoop to the enterprise. I mean, that's precisely what we are achieving.
Okay. Yeah, thanks. So I cannot able to call that as a distribution, so it is giving in a support from Hadoop ecosystem. I got that answer. Can I call like is there big SQL is supporting some kind of machine learning libraries, something like related to Mahout or C? For an example, I want to build my regression analytics on top of that data. Will my big SQL help me?
Yeah, so basically the way you will actually end up achieving that is you can use R, this open source R application. You can actually integrate R application onto BigInsights and achieve the same. If you're using SPSS, if you're using SAS, you can nevertheless go ahead and integrate those applications onto BigInsights platform and achieve what is required. So BigSQL will give you the SQL capability of performing the analytics. So how you actually end up consuming it, that will depend on your end integration.
Okay. Thank you so much.
I see a question on the chat channel around protecting data through big data. Like I mentioned over the slides, we definitely have an underlying governance mechanism, underlying security mechanisms that we support in the Infosphere portfolio. And one example could be using Guardian to basically audit your transactions, having security compliance as an example. If you have no other questions, you can definitely yet basically email me or post your questions on the big data community that we've launched. Okay, so we'll conclude this session for today, and just a reminder note that we do have a session at 3 p.m. today around Infosphere Streams Toolkits, the enhancements to the toolkits around geospatial and time series. So please do leverage the session, and yeah, so thanks all for joining, and we will conclude this session.
Excuse me. Hello.
Is there a question?
Yeah, hi. I wanted to ask one question that this conference, has it been recorded also as well?
Yeah, so I think, yeah, definitely the conference is being recorded, and as applicable, basically details on the slides, pruned down version of the slides, and as applicable, will be made available on the big data community.
Okay, that would be on the community. Okay.
Yeah.
Thanks.
Okay, thanks again. I conclude the session, and thanks all.
I'm sorry, this call cannot be connected.
Your conference is ending now, as requested by the host.